Hello everyone, my name is Miles Tessier. I am a senior at Nova Southeastern University School, and today's topic is going to be global warming. So for my project, I need to know what global warming is, how it's affecting our day-to-day life. Apparently global warming affects the air quality, so I want to do two things. First, I need to get some background information, so I did some research online. I learned that global warming is actually affecting the temperature of our Earth, and when it gets too hot, it actually uh, melts all the glaciers, all the ice down, so our sea level rises. Temperatures get hotter and hotter every single year in the past few years. But I needed to know more, so I emailed a bunch of experts in the field, I would say, of global warming and climate change. And I'd say I about emailed like 20, and one responded. So the one that responded was Dr. Miller. Now, Dr. Kathleen Miller is a senior research associate at UCAR. She currently lives in Colorado and is retired from teaching. These are some of her hundreds of publications. She is working with NASA on a climate change plan regarding the use of solar panel usage in all households by 2023. Again, thank you, Dr. Miller, for allocating the time to meet with me. Hello. Why don't you introduce yourself?
Okay, well, I'm Kathleen Miller. I'm retired from the National Center for Atmospheric Research in Boulder, Colorado, but I'm working on the Intergovernmental Panel on Climate Change Working Group 2, which is Impacts and Adaptation report that's due out in about a year. And I'm working on the North America chapter for that. My area of expertise is impacts of climate change on water resources and actually other natural resource systems, but my background is actually economics.
Oh,
But I worked at the National Center for Atmospheric Research for 35 years, so I have quite a bit of background in the atmospheric sciences.
okay. So for my project, I have this Zoom call is basically for an introduction to climate change and global warming.
Okay.
So for people watching this video that don't know what global warming is, what is global warming?
Okay, well, it's when we talk about anthropogenic global warming, we're talking about the additional contribution to warming that's caused by activities like burning fossil fuels, uh, making cement, anything that increases the concentration of greenhouse gases in the atmosphere. And that's, carbon dioxide, methane, nitrous oxide, various other gases. And what a greenhouse gas does is that it allows solar radiation to pass through to the Earth's surface, but it blocks some of the outgoing infrared radiation, and that tends to heat the surface of the planet. The thing is, that's a natural process. If we didn't have carbon dioxide in our atmosphere, Earth would be too cold to support life. And so, what's happening now is that we're adding additional carbon dioxide to the atmosphere and you're warming it up more. And that's going to have some effects on the whole climate system that will, alter, where the temperatures will be warming all over the globe, but the whole, uh, uh, movement of the atmosphere and location of intense precipitation and droughts and all of that will be affected by this change in the whole what we call radiative balance.
Yeah, so my project is regarding how the coronavirus is impacting climate change, global warming. Um, we've heard the president say before that global warming is a hoax. So how do we know global warming is real?
Well, okay, there's a lot in that question, but we know it's real because we understand the way that greenhouse gases work. And this is something that's been known for, well over 100 years, how carbon dioxide and other greenhouse gases affect the radiative balance of the atmosphere. And we also can observe the changes that are already happening. If you look at, decade by decade, the average temperature
It's gone up.
surface of the earth, it's been going up.
Yeah.
Uh, and the warmest the warmest years have all been happening very recently. And if you look at places like the Arctic, where the projections suggest that the greatest warming will occur, that's just what's happening right now. In fact, the past several years, it has been much warmer than long-term average, and that's affecting the whole circulation of the atmosphere. And where we're having cold outbreaks because the jet stream's gotten loopier, and
Right. What's a jet stream? Sorry.
those are the upper level winds that drive storms around the surface of the globe.
Got
And
it.
so, sometimes they tend to move straight across, and other times there's a really deep loop in the jet stream. And so cold air from the up north is pushed down to the south into the middle of the country, in the U.S. And then warm air is pushed up into places like Alaska. And the past couple of winters, we've seen that kind of very loopy pattern. And so you see these kind of wild extremes in weather that you wouldn't see so much if you had a smoother, less wavy jet stream.
Yeah. So my next question is, like, we see now people aren't driving because of the coronavirus, and carbon monoxide levels are going down, and the air quality is getting cleaner. So what are the impacts of global warming, like have in the future? You know what I mean?
Well, okay. So this period that we're in right now, where people are driving less and so on, that is reducing the rate of increase of the greenhouse gases.
Hmm.
Um, the ambient levels are still very high, and so we're not going to stop global warming by staying in our houses for this short, hopefully short period of months. Might slow it down a little bit. One of the things that we're seeing though are some of the side benefits of having cleaner air. You can see the mountains in places that you
Yeah.
could see them before, and people are realizing that, gee, clean air is a nice thing to breathe. Being quieter, you can hear the birds sing and all this sort of thing. But holding people in their houses isn't quite the way to solve the global warming crisis. We want to be more efficient about how we use energy and use cleaner forms of energy than we've typically been using in the past, so that we can still enjoy the benefits of a vibrant economy, but do it in a way that's not going to be so damaging.
Yeah. So I want to talk about, like, uh, sea this how the sea level is rising, and
Yes,
how that, like, a cause to that is global warming. So
that's
can you explain the process there?
well, okay. As you warm water up, it expands. Have you seen a pot of water boil?
Yeah.
Well, it expands. So that's part of it. A lot of the heat that's being trapped in the climate system is going into the ocean. And so the oceans have been warming and they're expanding for that reason. But the other part of it is that any ice that's based on the land, when it melts, that water goes into the oceans, and that is raising the sea level. So you've got the two things going on, and we're seeing a great deal of ice melting over places like Greenland and Antarctica, and just northern land masses,
Hmm.
northern Canada.
Glaciers. Yeah. So we need to find a solution to this soon because eventually it's gonna like kill the human race. But how soon do we need to find it? Like how like the impact on a day-to-day basis, how detrimental is it to like the earth like warming up and, you know.
Well, the sooner we take action, the better, because it's like you know, a big ship. You can't turn it around quickly. Okay, you the more we do soon, the better off we'll be. The goal is to hold the ultimate warming, well below 2 degrees Celsius, and
Mhm.
preferably uh, below 1.5 degrees Celsius. Although that's not looking really feasible uh, at the rate we've been going.
Mhm.
What you really want to avoid are those high emission scenarios where you see much greater warming, because that's really going to be detrimental. And so one of the things that we're doing in the scientific community is trying to identify, what kinds of adverse impacts you'll get with different levels of warming. And so it looks like, well, yeah, the more we can control it, the better. And there are lots of things that can be done. Transitioning to solar and wind power, that's a big start. And just generally, trying to preserve natural landscapes, forests that can absorb some of the carbon dioxide, and uh, all of those things would be very beneficial. And there's really no reason to stall on taking action.
Okay, so what are a few, so like we know you just said solar panel, big one. Some of the solutions to fighting global warming and like making a halt to it. Like what are some solutions that you've experienced that helps it in some of your experiments? So yeah.
Well, okay. I mean, solar panels and so on are almost a no-brainer now, because they're becoming so efficient that they're really cost effective. Yeah, I've got solar panels on my house, put them on about 8 years ago, and they've already paid for themselves. And I have not actually paid a penny for electricity in all that time, because the panels produce more than I use. So we can do a lot of things like that. um, and I think avoiding deforestation is another thing that would be really helpful. um, and and then just being prepared for dealing with the kinds of changes that we know are coming anyhow, because of all of the greenhouse gases that are already in the atmosphere. And trying to protect our communities from the kinds of impacts that we know that now not avoidable, like sea level rise. So, don't build a beachfront house if it's going to be wiped out in, the next big storm surge.
Yeah. So final question, what are we doing now to fix the problem?
Well, there's a lot of action at the local levels, and a lot of communities and states have made pledges that they're going to try to move towards what we call carbon neutrality, so that we're not putting net carbon into the atmosphere. We're taking it out to the extent that we can, and we're using the clean energy sources to avoid putting more carbon in. And there are a lot of private companies that are investing in new technologies that improve the efficiency of renewable energy and the storage of that energy. That's one of the problems with both wind and solar, is that they're a little bit um, intermittent. the sun doesn't always shine, doesn't shine at night, and the wind doesn't always blow. And so you want to be able to store the energy when you have it, and be able to use it later when the wind's not blowing or the sun's not shining. And so there've been a lot of effort going into creating more efficient batteries to allow that.
Okay. Thank you so much for doing this. I just sent
Okay.
for people watching this, I literally just sent a quick email and she responded to me within a day. It was very nice of you to do this for a high school
Okay.
student. Thank you
All
so
right.
much. It means
Well,
everything.
if you want, I can send you some resources too. Uh,
That would be great. Step 1, label the jars. Okay, so we have our 3 jars. So jar A will be the carbon dioxide inside by igniting the candles in the jar, along with the 4 ice cubes in a warm area. Jar B will be 4 ice cubes in a warm area. The control will be 4 ice cubes in a setting like this, where it's AC, it's not going to be outside. So, yeah. We're good. We're good. Hello guys, I just want to explain the experiment real quick. As you can see, this is the data from the experiment. So we have our 3 jars, jar A, which was with the candle, the carbon dioxide, along with the heat from the outside. Jar B was just the heat from the outside, and the control was literally just AC inside my house. So jar A, the average time was around 27-28 minutes. Jar B, around 43-44 minutes, and the control was an hour and 35 minutes. You can really see there's a difference between all the jars. Like every single jar has a different quota, a different average. So jar A was the one with the carbon dioxide, along with the heat that the outside brought, and the temperature outside. So it was around 85 or 86 degrees outside, and of course the sun does not help the ice cubes melting. So the average time for jar A was 27 minutes. And trial 1 we see 29 minutes, trial 2 31, trial 3 was a little on the outside of the grid, which was 23.5, but along the lines, it's pretty close, and you can see that the carbon dioxide really affects the amount of time that the ice cubes melt. So imagine all the carbon dioxide in our air, and even if it's like a 0.5% faster, it's still bad for humanity in general, and we need to fix this eventually. So in jar B, we literally no carbon dioxide in the jar. We just left the jar outside in the heat, and we see trial 1, 41 minutes, trial 2, 46 minutes, trial 3, 44 minutes. So this was a little slower, and we honestly can't do anything about this as humans, because that's just our climate. Control 95 minutes, roughly an hour and a half was our average time. Trial 1, 97 minutes. Trial 2, 102 minutes. Trial 3, 86 minutes. So the control was just an AC, no heat affecting the jar, and yeah. So as you can see, our control lasted the longest, then jar B, then jar A. So jar A was mainly what I was focusing on. It literally shows the difference between having carbon dioxide excess in the air, and jar B is moderately like where we should be, especially in Florida. So the control, that should be like worldwide, because that adapts to all climates, like say Canada. I mean, it's cold up there. Russia, Florida is just a hot place to be in general. So I mean, jar B should be a little higher if we were somewhere else, but it is Florida, so kind of kills the results. But yeah. Okay, so I just want to do a quick overview of this experiment and what I learned. So, global warming is a gradual increase in the overall temperature of the Earth's atmosphere, generally attributed to the greenhouse effect caused by the increased levels of carbon dioxide. Carbon dioxide was the candlestick inside of the jar, which caused the ice to melt. Like, drastic difference from the control. Okay, so the effect of the carbon dioxide in the air. So the carbon dioxide causes about 20% of Earth's greenhouse effect. Water vapor accounts for about another 50, and then the clouds for 25%. Likewise, when carbon dioxide concentrates and rises, air temperature goes up, and more water vapor evaporates into the atmosphere, which then amplifies greenhouse heating. So this was a pretty simple chart, like a simple diagram of the greenhouse effect from University of Columbia, and I thought it would be important to add it. So as you can see, the solar radiation hits the Earth's core, and then the greenhouse gases are released into the air, which makes the air temperatures go up, and more water vapor evaporates into the atmosphere, which then amplifies the greenhouse heating, which is crazy. This was Dr. Miller's assessment. Scientists who assess the planet's health see indisputable evidence that the planet has gotten warmer, in some cases rapidly. Most believe that humans actively in the particular burning of fossil fuels and resulting buildup of greenhouse gases in the atmosphere have influenced this warming trend. So, if you didn't know, the Earth in the past, I would say 100 years since 1950, I thought I read on National Geographic, has been increasing dramatically, and I think I have a chart on here later that you'll see, but there's indisputable evidence that what we are doing, like burning fossil fuels with our cars, with our homes, all of these differences have caused a massive increase in the air temperature, and it's just making our globe, the Earth in general, the planet, warmer. So we need to stop. We need to create a solution, and it needs to be fast. Okay, so let's talk about the water temperature real quick. The oceans have absorbed much of this heat as well. So the water temperature has gone up more than 0.4 degrees since 1969, and that to me is incredible because, again, I looked at a chart, and it hasn't increased that much in 10,000 years. So to see that in 100 years, like I'm only 18, like to see that in 100 years, that amount of, let me go back. Oh no. That amount of drastic increase is crazy. All right, next slide. Okay, so for this diagram, I thought it was really important to show that the carbon dioxide level has increased dramatically throughout time. So we start at the beginning 800,000 years ago. So it was around 200. And obviously, it goes up and down through time. So around 2,000 years ago, or 200,000 years ago, we see it was at 260. And then it went right back down to around 180, and then spiked up at 280, and then we see the 1950 level, it was at 300. So in 1950, it was at 300. That matched the all-time highest level. Its current level is at 417 or 400. Let's just say 410. Again, it's been 100 years. That is, look how many years have gone by. 800,000 years, and in 100 years, it increases 200 up at its highest level. So clearly, we're doing something wrong. We have to fix it. So this is just amazing to me, how dramatic the increase is. Of course, the population has gone up, but it's always been going up, and we still see the up and down pattern, but now it's just skyrocketing. So you can power your home with solar panels. I know it's expensive to start up, but Dr. Miller, she actually innovated her whole home with solar panels, and it's been, I think she said it was 8 years now, and now they're just paying for themselves. So she made her money back. She has free energy. She's saving the planet. Great investment. Okay, let's just skip a couple of these. Invest in energy efficient appliances. So you could let's just say a car. Like, you don't need to use gas. You don't need to like burn fossil fuels. Like, use energy that doesn't involve the burning of fossil fuels. Also, actually eat the food you buy. A lot of Americans, if they see it's expired, they dump it. Try to avoid that. Buy what you need. Know that you need to eat this food, because the less food that Americans and people in general eat, the better for the animals and greenhouse gases. So we need to stop. We need to stop buying so much meat, because it contributes to the producers making more of it, which increases the greenhouse gases. Okay. So buy better bulbs. Buy bulbs that will last. Don't buy the cheap bulbs that last a month and you have to throw them out, because again, that contributes to greenhouse gases. Okay. Drive a fuel efficient vehicle. So if you can't purchase an electric vehicle or a vehicle that doesn't require gasoline, drive something that has like 30, 40 miles to the gallon or something like that. I don't know what the thing is. Do something higher than average. Don't buy like a big truck that gets like 10 gallons, like 10 miles to the gallon or something like that. I don't know. So drive something that will last long in your tank. Okay. Some solutions. Moving away from burning of fossil fuels is huge. So eventually, I believe in a couple years that everyone will be driving electric cars, which is great. We're going to see a dramatic decrease in the Earth's temperature. I think that would be great. So use solar energy as best as you can. If you can't afford it, it's fine. But if you can't afford it, do it, because you're going to save the Earth and the people in our next future generations. Okay. Eliminate the excess of greenhouse gases. Yeah, we need to stop buying too much food and then throwing it out. I mean, so many people can use that food. Why don't you just budget? It saves you money. Just buy what you need. Don't buy because you want to, and just in case, to be safe. Buy what you need. That'll help the planet. That'll help other people. That'll help you in general. Save some money on your grocery bill. So yeah. And thanks. It's funny.